more definitions and properties. So moving on, some of these are going to be review, and some of these are going to be new things that we're also going to be using in our proofs. So first of all, we need to remember what an acute angle is. So an acute angle is an angle less than 90 degrees. So we could draw a pretty small angle, and let's say in there is 10 degrees. That's an acute angle. A right angle is exactly 90 degrees. So think about the corner of a piece of paper. You should be able to stick that corner right in that box. And the way we mark a 90-degree angle is with the box. So if you see that, I'm telling you it's 90 degrees. An obtuse angle, an angle larger than 90, but less than 180. So for example, we could kind of do something like this. And then in here we could say, okay, well, 110 degrees, that's an obtuse angle. A straight angle, okay, so a straight angle is exactly what it sounds like. I'm going to draw the picture first. Is a straight line. So right here would be your straight angle, is exactly 180 degrees. Adjacent angles, next to each other. Okay, so an example of this would be if we were to take, let's say, an angle that looks like this, and then I would take my vertex and I would draw another ray. Then this angle right here and this angle right here are adjacent. So another way to say this is they share a side, or they share a ray. So right here is the side that they would share. The top one has the black one and the green one. The bottom one has a different black one and then also the green one. Angle bisector, we should already know this because we have a theorem about it. Cuts angle in half. Okay, so if I have an angle, let's say I have a 90-degree angle. So I'm going to put the box here. And then I draw an angle bisector. If that is an angle bisector and that's a 90-degree angle, then how much do I know this and this are? And that would be 45 and 45 because it cuts it in half. So then the two other angles formed are congruent or are equal. Perpendicular lines intersect at 90-degree angle. So if you're drawing your picture, if this is one of my lines and this is one of my lines, perpendicular, 90-degree angle. So those are perpendicular lines, they intersect at a 90-degree angle. Parallel lines never touch. Okay, they have the same slope. So if one's going like this, then the other one's going like this. Now, the way we show parallel lines is you can put little arrows on them. So if you see those little arrows, that should remind you that those are parallel lines. They're never going to touch. Complementary. Add to 90. So let's say I have one angle over here. I'm going to tell you this is 80 degrees. Then I have another angle over here. Okay, if these two are complementary angles, and I know this one's 80, then how much does this one have to be? And the answer would be 10, because they're complementary. So 80 plus 10 is 90. Supplementary. Add to 180. So for this one, I'm actually going to draw a straight angle. Okay, straight angle. And then I'm going to take my vertex and I'm going to go like this. And so these are now two adjacent angles because they're touching and they share a side. And I'm going to say that this one is 160 degrees. So if this one's 160 and this is a straight angle, also supplementary because it adds to 180, then how much would this one be? 20 degrees. Okay, congruent, same shape, same size. So for our purposes, essentially, we're looking at equal. So if I have one angle, and this could be an angle, this could be a ray, this could be anything, can be congruent, but specifically an angle here. If this is, let's say, 30 degrees, and these are congruent, then this would also be 30 degrees. Okay, now at that point, that should be review. I'm really hoping you knew all of that because that was review. These last two boxes are our important ones, okay, and these are actually more theorems that you're going to use proving things. So the first one is vertical angles, and then we're going to have the vertical angle theorem. Okay, so this theorem is going to be used when we do proofs. Now, vertical angles are angles that are kind of opposite one another. So if you have intersecting lines, then the vertical angles are this one and this one. Okay, so they're opposite each other. The other set of vertical angles here would be this one and that one. Okay, because they're like opposite each other. They're on opposite sides, like across from. And then the vertical angle theorem says that vertical angles are congruent. Okay, so if this green one is, let's say, 60 or 70 degrees, then this green one is 60 or 70 degrees. If the red one is like, I don't know, like 90, then this one is 90. Whatever they are, they're equal to each other. This is important. Okay, right? Important, important, important. Also important, linear pair. Okay, this is the most commonly forgot one that we can use. Linear pair is literally linear, which means line, pair, which means two. Two angles on a line. Okay, so if you got two angles on a line, kind of looks like this picture up here. Okay, first of all, that's a line. That's a straight line. What do we know that a straight line is? Well, that's 180 degrees. So if we got the two angles on the line, so we've got this one and then we've got this one, okay, linear pair add to 180 degrees, okay, also known as they are supplementary, okay, so I can write that as well. Also very important, also going to be used in proofs, so don't forget about that one.